Incentivized and secure blockchain technology makes transparent, decentralized, token-controlled networks possible for the first time. And the potential for what can be done with this is enormous. It's the reason a new era of the web is underway. Hi, I'm Amy James, and welcome back to What Kind of Internet Do You Want? Today, we're going to talk about blockchain technology, what blockchains are, the invention of blockchain, the first blockchain to go mainstream, and why the Bitcoin blockchain unlocked Web3. But before we start, please hit the like button and subscribe to the channel, and let's get into it. Okay, so first, what is blockchain? In its simplest definition, a blockchain is a public database that records transactions across a network of computers. What distinguishes a blockchain database from a conventional database is that it's entirely decentralized. It lives on and is shared by many computers across a vast network with no one computer owning or controlling the database more than any other. Unlike typical databases where an administrator has more control over it than the other users, blockchains have a flat hierarchy where everyone has the same ability to read and write data to it. Blockchain transactions are accumulated into groups called blocks, and those blocks are then securely linked together in a chain according to the sequence in which they were created. Because each block is linked to the previous block and the full blockchain is distributed across many computers on the network, the data in blockchains cannot be falsified without the entire network being alerted. And this gives blockchains the unique qualities of security and trust. Okay, so now let's talk about the invention of blockchain. Where did blockchains come from? It would be reasonable to think that the first blockchain was Bitcoin since it was the first one to get popular, but surprisingly, blockchain was first invented way back in 1991 by Stuart Haber and Scott Stornetta while working for Belcore Labs. This was actually right around the time that Sir Tim Berners-Lee was introducing the World Wide Web, and I just think it's really interesting to note that there was a lot of technical innovation during this period that was really important, but that took a lot of time to develop into its full potential. So after learning about an academic scandal involving falsified biology research results, Haber and Stornetta sought a way to ensure that digital records could not be faked. Their solution used cryptographic hashes to track changes in data. A hash is a series of numbers of a predetermined length. They're made by running original data like an email or a financial transaction or a research report through a hashing algorithm. Because of the way hashing works, if any of the original data is changed even by a tiny bit, like a single letter or even just a space, the resulting hash would be completely different and easily spotted as fraud. In other words, no more fake biology reports. Haber and Stornetta also time-stamped the hashes and figured out how to link them and then accumulate them into a block of data through a cryptographic method known as a Merkle tree. So that pretty much sums up what a blockchain is. It's a series of immutable digital records grouped together into blocks of data and linked in a chain. But Haber and Stornetta's blockchain didn't have a flat hierarchy. It relied on a centralized service for the timestamping. And this type of problem is a major recurring theme with centralized, hierarchically controlled databases. Someone with higher access can make an error or, with the wrong motivation, do something unethical. And this was kind of the Achilles heel of Haber and Stornetta's blockchain. They had a good idea for how to manage the problem that really foreshadows the ultimate solution. They wanted to enlist the help of many people to witness the chain of hashes so that there would be a permanent, immutable public record. But unfortunately, the best option that they had to do this with back in 1991 was to take out classified ads in the New York Times listing all of the hashes in their blockchain, which isn't a very 21st century idea. Haber and Stornetta's blockchain could work reasonably well within an organization of people who knew each other and trusted each other, but it still had the weakness of a hierarchical structure, and it couldn't work for the flat hierarchy of a decentralized network of unknown users because they didn't have a great way to ensure that someone couldn't manipulate the centralized timestamping service, which would tamper with the reliability of the data, and they didn't know how to delegate the responsibility of storing new blocks in the chain in a way that didn't depend on trusting an authority. And so blockchain technology existed, but it didn't catch on for the next 17 years. Okay, so now let's talk about how blockchain went mainstream. In 2008, building on the research of Haber and Stornetta, an unknown developer or group of developers working under the alias Satoshi Nakamoto published the now famous paper called Bitcoin, a peer-to-peer electronic cash system. In this paper, Nakamoto combined the pre-existing blockchain concept with two other technologies: public key cryptography and proof of work. We have a video coming up all about public key cryptography, and when that video comes out, we'll link it here. But the best analogy for how public key cryptography is used in the Bitcoin blockchain is to think about writing a check. When a bank goes to settle a check, it needs to confirm that the account number and the account name of the payer and the receiver are valid, that the authorized signatures match, and that the payer's account has the money to cover the check. A public key is a kind of digital identity which declares who a sender or receiver of a transaction is, similar to a bank account number or a social security number. Public keys are paired with private keys that can be used to create a digital signature. Private keys are like the real names and authorizing signatures behind the scenes that give a user power over their account. Public key cryptography makes it possible to produce a reliable public record about any transaction, including the account where the funds are being sent from, the account where the funds are being sent to, the amount of Bitcoins, and an ironclad authorizing signature. Combining blockchain as the database and public key cryptography for identity with proof of work for network consensus and data security is really the magic of Satoshi's innovation. Proof of work is a system where the computers on the network form an absolute consensus over the historical contents of the blockchain while competing to confirm the next block. We also have a video coming up about proof of work, and we'll link it when it comes out, but the gist is that a network of computers compete to verify that both the last block in the chain as well as all of the recent transactions are valid, and then gathers up all of the recent transactions and engraves them into a new verified block of the blockchain with a reference linking it to the previous block. And since each block is linked to the block before it, the entire chain is totally immutable, and any change to any piece of data along the way would be instantly detectable. In other words, the decentralized network of computers is able to verify that all the transactions are valid and that the public key information is present and correct, just like the bank did in our previous analogy. But here's why it works. The user that wins the competition to write the next block in the chain is rewarded with a sum of Bitcoins. Satoshi called this the block reward. The block reward provides an incentive to do the work of verifying all the data in the blockchain. This was a really, really important innovation. Rewarding users for doing this competition and verification work was the missing link in making decentralization and a flat hierarchical database successful. Before Bitcoin, there were attempts at organizing decentralized projects like SETI at Home and Folding at Home. But even for projects that are literally reaching for the stars and trying to save lives, they produced far, far less output than Bitcoin, simply because they did not include a financial incentive. Bitcoin's block reward incentive mechanism not only made the Web3 vision possible, it made it economically sustainable. And that brings us to why Bitcoin unlocked Web3. By putting blockchain, public key cryptography, and proof of work together to create Bitcoin, Satoshi Nakamoto created the most significant revolution in money in more than 600 years, ever since the Medici's introduction of the double entry bookkeeping system. Instead of relying upon a central authority like a bank or a time-stamping service, a decentralized network of users simultaneously and unanimously verifies Bitcoin transactions. Satoshi's blockchain is the first triple entry ledger, which means that not only the sender and receiver of the transaction have a copy, but there's also a third party to every transaction, the public at large. While Bitcoin is absolutely revolutionary, there's reason to be excited that goes way beyond financial transactions. The combined elements of an immutable record-keeping structure, such as blockchain, a digital identity mechanism like public key cryptography, and a consensus mechanism like proof of work are what make the vision of a totally decentralized Web3 possible. But blockchains aren't just about financial services. The Bitcoin model can be applied to file storage, cloud processing, video transcoding, content indexing, and so much more. Really, the kinds of things that are responsible for the services that we use on the web every day, like Dropbox, YouTube, and Zoom. Incentivized and secure blockchain technology makes transparent, decentralized, token-controlled networks possible for the first time. And the potential for what can be done with this is enormous. It's the reason a new era of the web is underway. And that's it for today. If you enjoyed the video, please hit the like button, subscribe to the channel, and share it on social media to help us spread the word about the power of blockchain and what it means for the future of the web. Thanks for watching, and I'll see you next time.